Welcome. Today we present a derivation of the quadratic formula. This is an equation that appears so frequently throughout the sciences and mathematics that it deserves a spotlight all unto itself. As a matter of fact, one of the earlier videos that we did, you may recall the Giancoli 2-44 Physics Police Speeder 1D Kinematics Solution. There at about minute 720 and beyond, we showed a quadratic equation and then we solved it without really justifying how we did that. So in this video, we hope to show not only a derivation of how the quadratic formula comes about, but we also want to show at the end some of the details of the steps involved to solving that equation that we presented in that earlier video. To actually derive the quadratic formula, we're going to use a technique known as completing the squares. And we'll talk about that here in a moment. Oftentimes, I may just abbreviate quadratic formula as QF. Okay. Now, let's begin at the top. What is meant by a quadratic equation, or just the word quadratic in itself? Here, in this context, when we say quadratic, what we're really saying is we're talking about a single variable polynomial of degree 2. If we go to higher degrees, we would encounter a cubic equation. So for example, going higher, we would encounter a cubic. This is a polynomial of degree 3. A quartic. This is a polynomial of degree 4, and so on. Graphically, it's also interesting to see what we're talking about here. When we're talking about a quadratic, graphically, if you were to take the variable to be x, I could say that this is my x-axis. Then what I'm really expecting to happen with the quadratic is for the graph of that function to do something like this, such that the graph crosses the x-axis at two distinct positions along the x-axis. And so because I have a second degree polynomial, I'm expecting to have two roots to this equation, or two zeros. So formally we would call these the two zeros of our quadratic. Okay, so let me formalize this just a little bit more. When we talk about a single variable polynomial of degree 2, what we're really talking about then is the following. We're saying that it is an equation of the following form: ax squared plus bx plus c is equal to 0, where a, b, and c are constant coefficients, specifically a is the quadratic coefficient, okay? B is the linear coefficient, and c is just the constant coefficient. Well, it's just the constant term. Let me call it the constant term. Okay, so in the case that we have before us, the quadratic formula or the quadratic equation, which is this, notice that we have three terms. We have a quadratic term, which is the first term here, and we have the coefficient of the quadratic term, which is that. Then we have a linear term here. So this is the linear term. This is the quadratic term. And then we have the constant term. So really there are three things that you really need to consider as we go through this, and it's not that demanding if you break it down in your mind as only being three things to keep track of. Okay, now to try and get at a solution to this, in other words, where are these guys crossing the x-axis? We want to figure out, our objective is finding out the values of x such that the graph is crossing the x-axis there, and we expect there to be two of those, okay? So let's take a look at how we can go about doing this. Well, the first thing that we would do when we begin with our equation is let's divide both sides by the constant a. And notice that the quadratic coefficient a has to be different than 0. If you wonder why that is, you may want to look at my division algorithm video where we explain that when we're talking about a polynomial of a particular degree, in this case degree 2, the leading coefficient must be non-zero. Otherwise, if it were to be 0, then it would not be a polynomial of that degree after all. So because the leading coefficient, the quadratic coefficient, is different than 0, I can divide both sides by that quadratic coefficient, in this case a, and if I do that, I'm going to get an x squared plus a b over a term times x plus a c over a, and all of that's going to be 0. And now what I would do next is use the method that I referred to earlier, known as completing the squares. Let me say, let's complete the square. And so to do that, what we say is, we'll take the x squared term, I'm going to write that as an x, and then I'm going to take half of the second term, okay? So I've taken x plus 1/2 of that other term, b over a, and then I'm going to square that. I have still the plus c over a term, which is that term, but because I've added a, now let's look at what we added in here. We added a b over 2a being squared, so I need to subtract that out to keep everything the same as it was before. So I'm going to subtract out a b over 2a squared term, which is this term right here, when you square it. Okay? Now let's just look and see that I haven't really changed anything at all. Let's go ahead and square this leading term out. So I'm going to do a quick check to ensure that whatever I've written is what we started out with, so we haven't changed anything. So if I have x plus b over 2a, and that's being squared, I could write that as the quantity x plus b over 2a times the quantity x plus b over 2a. That's all of this stuff here. Okay. Plus the c over a, that's this term here, minus the b over 2a squared term, which came from this inner term that I've circled here when you square it. Let's do this and just check to make sure that we have not altered our original equation, which is this one right here. So x times x is x squared, plus we get a b over 2a times x when I do this product, okay, plus I get a b over 2a times x when I do this product, and then lastly I get a b over 2a times a b over 2a when I do the last term product. So what I did here is known as FOIL. Okay, first, outer, inner, and last is what we did there, plus the c over a minus the b over 2a being squared. Okay, all right, so now we have x squared. I have plus, I have a b over 2a times x plus a b over 2a times x. That's two of those terms, so I get 2b over 2a times x terms. That's from these two guys. Plus I get a b over 2a times a b over 2a. I could write that as a b over 2a squared, plus a c over a minus a b over 2a squared. You'll notice right away that this plus term knocks out that minus term. And so what we're left with then is the following, and also this 2 knocks out that 2 on the downstairs. So we're left with x squared plus b over a x plus c over a is equal to 0. And in fact, that's what we had started out with, okay? So we have not changed anything by writing the equation in this form. Okay? So now I'm going to take this equation, since it's the same as this equation, we haven't altered anything, and I'm going to solve for, try to isolate this unknown x term. Okay? So let's go and do that next. So if I come out here, what we want to do now is to, let's solve for x. Okay, so we have x plus b over 2a squared. That's that first term which I've circled here. I'm going to take all these other terms which are independent of x. There's no x in the c over a or the b over 2a whole term squared. There's no x there, so I'll just go ahead and take those to the other side. And that's why we did the completing the squares technique, to isolate the x all by itself, by the way. So then I get here b over 2a, that term squared. It was minus up here, now it became plus on the other side of the equality, minus the c over a. And now we're going to take the square root of both sides. I abbreviate square root of both sides this way. Okay, so if I take the square root of both sides, I get x plus b over 2a is equal to the square root b over 2a, that term squared, minus c over a. And we have to be careful here because I have to put a plus or minus when I'm taking the square root of both sides over there. And so there is the plus or minus being accounted for. Now, notice that I'm getting awfully close because I have an x here, but I've got this plus b over 2a term. So to really isolate the x, I'm going to subtract out both sides of this equation by the b over 2a term. So that means that I get x is equal to, and let's take this to the other side, it becomes minus b over 2a plus or minus, I get the square root of, now let's square this out. I get b squared. The square of 2a on the bottom becomes 4a squared minus the c over a term there. Okay. Now, I would like to get a common denominator between here and here. So, let's get a common denominator. Okay, and so you can already see what the common denominator should be. I should multiply top and bottom of this second term by 4 times a. That'll give me the 4a squared. So I get, if I continue here, I'm getting x is equal to minus b over 2a plus or minus the square root of b squared over 4a squared minus 4 times a over 4 times a times c over a. That gives me then the common denominator of 4a squared down here. Okay? So this will be x is equal to minus b over 2a plus or minus the square root of b squared minus 4ac over 4a squared, which was the common denominator. And lastly, you'll notice that 4a squared sitting on the bottom here, all being square rooted, you'll notice that that's a perfect square. So I can take that out. I get a x is equal to a minus b over 2a plus or minus the square root of b squared minus 4ac. I'm taking the square root of 4a squared, becomes a 2a. And then finally, you'll notice that, in fact, this here, we have a common denominator of 2a, and so we will wrap all this up by writing this in the familiar form, minus b plus or minus root b squared minus 4ac all over the common denominator of 2a. And here is the quadratic formula that we just derived. Having done that, now let's revisit something that we had done in an earlier video. So in an earlier video, namely from this video here, where we had the Giancoli 2-44 Physics Polyspeeder 1D Kinematics Solution, particularly at this minute mark, we had started to talk about an equation, and the equation was the following. Okay, so the equation we had there was something of the form like this. We had t tilde squared plus 26.4 minus 37.5 times t tilde minus 11.1 equals to 0. This was at the minute marker of 8 minutes and 15 at 0815 of this video up here. And if you go ahead and do the subtraction here, you will find that this is an equation that looks like this. In fact, 26.4 minus 37.5 is a minus 11.1 t tilde minus an 11.1. And notice that I now have something of the form a times x squared plus b times x plus c is equal to 0, okay, where you'll notice that this, what I'm calling t tilde, is like my x, and in front of the t tilde here, there's understood to be a 1 as the leading quadratic coefficient there. So the a is the 1, the b here is the minus 11.1. Of course, the t tilde we just said is the x, and this constant term out here is the minus 11.1. So in this particular problem, both b and c are equal to each other. So let's go ahead and apply this formula that I have in the box here, which is the quadratic formula. Let's go and show the details of applying that here. Okay, so we have, let me just write that here. We have the quadratic formula is x is equal to minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a on the bottom. Okay, so we're going to apply that. We note here a is 1, b is minus 11.1, c is minus 11.1. So let's just go ahead and also, our t tilde, our x in this quadratic formula is what we're calling the t tilde. Okay? So if I use this formula, I could say, therefore, for this equation, the t tilde, now t is, of course, a symbol to remind us that it's time that we're talking about. T tilde, using this formula here, is going to equal minus b, so it's going to be minus times a minus 11.1 plus or minus the square root of minus 11.1, that term being squared, minus 4 times a times c, all over 2 times a. Okay, so if you do this, you're going to find that you get t tilde is equal to 11.1 minus times minus is plus or minus the square root of, and then you're going to get some term in here. Let's see what that is. I have to compute that real fast. Bear with me for 1 second. Okay. Looks like it's the square root of about 167.61 all over 2. And so if you do that, now the square root of 167.61 is about 12.95. So this here, this is about 12.95 roughly. So you're going to get two roots. If you take the plus root, that is to say 11.1 plus the 12.95, all divided by 2, you're going to get a 12. It'll be about 12.02 or 03 roughly. And if you do the minus, you're going to find it's a minus 0.92, and these were in units of seconds. And in that video, you'll remember that we rejected this root because, in fact, we expect time to be positive. But that doesn't change the fact that we still got two roots. That is to say, if you come back up to this graph here, it's possible that whether I'm talking about x or in the present context when I was talking about t tilde, as my variable, it's possible that we have a plus root which is sitting on to the right of this ordinate axis, and we have a minus root sitting to the left of that, and in this case we're rejecting the minus if in fact this abscissa axis is in terms of time and seconds, because we expect time to always be non-negative. I hope that helped. There was a lot going on here between learning of polynomials and then completing the squares. To do that, we did a quick check. We used the method of FOIL to distribute and multiply these two terms out, and then we checked that in fact this equation was in fact what we started out with, and then from there we were able to isolate for the x, which is what we were interested in, and then arrive finally at this quadratic formula. And incidentally, if you haven't done this already, it would be highly advisable for you to go ahead and memorize this formula, because as I said at the beginning of the video, the quadratic equation or equations of degree 2 come up so frequently in the sciences and mathematics that it's just worth going ahead and memorizing this formula. Okay, I look forward to seeing you in a future video once again.